In the previous lesson on HM, we learned that due to epilepsy, HM underwent a radical brain operation. He had large portions of the medial temporal lobe removed, including the underlying hippocampal structure on both sides, and this left him with profound memory impairments. In this lesson, we'll try to understand why he had the symptoms that he did, and we'll relate it to the concept of system consolidation. First, why could he not make new episodic memories? Well, to understand this, let's take a look at just the connectivity of the hippocampus. The hippocampus is an important structure. It receives major inputs from all the high-level perceptual regions of the brain. So the visual system is sending information to the hippocampus, auditory system, and the touch system. And so the hippocampus is integrating all of that perceptual information to make a memory trace of an episode, of an experience. And so if you don't have a hippocampus, then you can't make new episodic memories. You cannot make a memory trace of some experience that you're having because you've lost the structure that is integrating all of those perceptual aspects of the experience. So the reason why he can't make new episodic memories is because he had lost that very part of the brain that was sort of responsible for making new episodic memories. Now, what about the gradient of memory recall? Remember, he did not have access to memories of events that happened just prior to surgery, but the farther back in his past, he had greater success in retrieving memories. What about that? Well, again, we have to now bring in the concept of consolidation. So the hippocampus that has made a memory trace of recent events, it will be involved in the consolidation process. Remember, consolidation is the reorganization of the memory. So the hippocampus helps to transform a recent memory into a long-term memory stored in the cortex. The cortical memory trace is going to be getting stronger, but this process takes time. And so when we think about this gradient of recall, it reflects this window of consolidation. It takes time for the hippocampus to teach the cortex to, in a sense, make those stronger memory traces in the cortex. And so if more time has elapsed, then retrieval will be better. If less time has elapsed, you didn't have much time for consolidation, then retrieval will fail. And what about the good recall for events distant in his past? Well, here the idea is that memories that were already consolidated in the cortex are going to be reactivated by other cortical brain regions. So, for example, the frontal cortex, other evidence suggests that it is active during memory retrieval. So certain regions of the frontal cortex may be able to reactivate consolidated memories without the need for the hippocampus. Now, the controversy between the standard consolidation theory, which was the first theory on the scene, and the later trace transformation theory involved HM's ability to recall distant or remote memories. Now, since he was able to tell the researchers about his early childhood, the researchers concluded that he was accessing this information, and he was having episodic memories of his early childhood. And so since he didn't have a hippocampus, it must mean that the hippocampus is not necessary for episodic memory retrieval. Well, the trace transformation team argued that this wasn't the whole story. A closer analysis of HM's retrieval of these early events showed that his descriptions of these early events were more like semantic versions of memories rather than reliving the episode in his life. They noted that HM and others could produce memories of their childhood, but they were schematic and lacking detail and vividness. They could remember that a birthday party involved cake and party games, but the detail of the episode was lost. So perceptual, temporal, contextual information was absent. Remote episodic memories were different. When the hippocampus was damaged, they resembled semantic memories. And so the trace transformation folks argued that HM was not really able to relive these old episodic memories. They were rather semantic versions. They were gist-like versions of his past. And so for trace transformation theory, then, the gradient reflects the time course of memory transformation, whereby episodic memories lose details and become more schematic or semanticized. More remote memories have gone through this transformation, so the cortical representation of remote memories contains general features, the gist of the event, that are independent of context. The hippocampus is required for recreating the detailed and vivid context of an event, so it can be recollected, no matter how long ago the memory was acquired. Therefore, without a hippocampus, recent memories cannot be recreated, and there is no cortical representation of the gist of the episode. For remote memories, all that can be retrieved are schematic versions of personal memories.